Hi, welcome back to Mr. Slover's Math. Today we're going to talk about graphing linear functions. So here's our warm-up where it's just asking to give the coordinates for the following points. Remember, when you graph or when you locate coordinates on a plane, you start at 0, 0, which is your origin, 0, 0, and you go right or left first and then up or down. So we're looking for point C, which is over here. So we go right first, which is positive, and then we go up, which is also positive. And that's how we got 3, 3. But today our focus is on linear equations. So a function that makes a continuous straight line when graphed is a linear equation. And a linear equation has a degree of 1, which means we don't have any exponents that are 2 or more. So these are examples of linear functions that you could see. It's just 4 examples. There is an infinite amount of possible answers out there. So y equals 3x, y equals 7, x equals -4, x minus y equals 0. Those are all functions. So if I were to graph them, it would be a continuous straight line. Now over here, these are nonlinear functions, and I tried to give a reason why. So if I have x, y equals 3, I can't have that as a linear function because my variables cannot be multiplied together. It wouldn't give me a straight line. Same thing on this one. I can't have a power of 2. I won't have a straight line. I can't have a variable in the denominator. I can have a fraction, so we can have a fraction, that's okay, but I can't have a variable in the denominator of the fraction. That's when it's not a linear function. And the last one says the y equals absolute value of x. So I just want to be clear that that says y equals the absolute value of x. Okay, this forms the letter V, is the easy way to picture it. So yes, the letter V does have straight lines, but it's not continuously straight. Okay, so it comes down to a point and then it goes back up in the other direction or goes back down in the other direction. So you're changing directions, and you can't do that when you have a linear equation. So example 1 is asking us to determine whether it's a function, asking us to determine if it's an equation or not. And if it's not, we got to explain it. So letter A, y equals 4 minus 3x. Well, I have everything. I don't have a power. I don't have my variables multiplied by each other. I don't have a fraction with a variable in the denominator. I don't have the absolute value. So I would say, yeah, it's a function. So letter B, same idea. I'm just going through of what a nonlinear equation would look like, since that's easier to spot than it is a linear equation. I have my variables multiplied together. Okay, x times y, I can't have that. And then same thing over here. I can't have a power of 2. So those two, letter B and C, are not equations, not linear equations. Example 2, there are 2 different ones here, A and B. We're just going to talk about A. Letter B is very similar. It says determine whether or not each ordered pair is a solution to the linear equation. Circle all answers that are true and show your work. So I told you right here that first you got to plug in x and y into your equation. Well, you may be thinking, where did the x and y come from? Well, 0, 8 is an ordered pair. Your ordered pair is always located at x, y. That is your generic form for an ordered pair. So x is 0, y is 8. So anywhere I see an x, I'm plugging in 0. Anywhere I see a y, I'm plugging in 8. So once they're plugged in, once I do this substitution, I'm going to go ahead and follow the order of operations, do multiplication first, and then subtraction. So -8 does not equal 8. So that's not a true statement. That's why I wrote no. It's not true. Now over here I have 1 and -6. So I'm taking 1 where I see x, plugging it in, and plugging in -6 where I see y. Now if I go back to the original equation, it says 2x minus y. So 2 times 1 minus, and then y happens to be a negative. So minus is what's my equation, and then my y value is -6. That's why there's 2 negatives there. So a minus negative becomes that positive, which is why I end up saying 2 plus 8. And so I end up with 2, and actually that should say 6. So 2 plus 6 equals 8. 8 does equal 8. That is a true statement. Okay, so note that this should say 2 plus 6. I accidentally wrote 8. So this is a true statement. So that means this is a solution. And I do the same thing for the last one. I plug in x is 4, y is 0, follow my order of operations, and I get a true statement. So I'm circling yes. Okay, I just chose to highlight it to bring your attention to it, that these two are solutions to my equation. Letter B is very similar. And down here on 3 and 4. So 3 has more information filled out, or more tips, so I'm going to talk about that one, but number 4 is the same idea. So it says graph the following linear function using the table below, work is required. So here's my function f of x, and remember f of x is a fancy way for us mathematicians to say y equals. Right, so it's really saying y equals negative 3x plus 1. And over here I wrote that I'm going to plug in for x. So anywhere I see an x, I'm going to plug in a negative 2, or a negative 1, or a 0, or a 1, or a 2. And in this column, these are my y values. That's why I wrote this means y. So I tried to color coordinate what's going with what. So if I plug in negative 2 into my equation, I get negative 3 times negative 2 plus 1. So I'm doing substitution just like I did in example 2, and then I'm following my order of operations. So 6 plus 1 becomes 7, and then that's it. I write 7 over here. Now I plug in negative 1. Negative 3 times negative 1 plus 1. Negative 3 times negative 1 is 3. Add 1, I get 4. And I just keep plugging different x values in. I'm using the same function, negative 3x plus 1. I'm just having a different x value, a different input. So if I substitute in 1, negative 3 times 1 plus 1. Negative 3 plus 1 is negative 2. And then the last one I plug in 2, I end up with a negative 5. Now down here I circled in green that these become my ordered pairs, because it does say graph. Graph the following linear function. Well, in order to graph, I need some ordered pairs. This table actually created ordered pairs. So this is saying x is 2, y is negative 5. So I have an ordered pair of 2, comma, negative 5. Or I have an ordered pair of 1, comma, negative 2. Or 0, comma, 1. Or negative 1, comma, 4. Or negative 2, comma, 7. So I have 1, 2, 3, 4, 5 ordered pairs. I have 5 points that are on here. Now when I graph them, it doesn't say to connect them. Okay? I just connected them because that's our end goal for this unit. We are going to graph a linear function, right? We're going to graph a straight line. So these should be in a straight line. So I'm connecting them to show you that they do form a straight line. If when you are graphing, they do not form a straight line, you either graphed wrong or you substituted in and evaluated incorrectly. And you would have to go back and fix it. Okay, so once again, these should form a straight line. So if I look at example 4, they form a straight line. That's what I want. So anytime you have a linear function, it is a continuous straight line. And then here you're just substituting in. It's just a table. Here's my x. Substitute it in. You get your y value. So if you have any questions, make sure you read